What's going on, everybody? Mr. Diamond, and today we're going to be focusing on writing half reactions and how we are going to be writing half reactions. So we're going to be doing this example problem. This is number 1 on your worksheet over just writing half reactions. I know I kind of combined the notes, I believe, over writing half reactions and balancing redox equations, but for now, we're just focusing on getting the half reactions down. So all we care about is figuring out what is oxidized, what is reduced, splitting that into its components. So let's go ahead and get going like we have been. We've got Li, we have Zn, we have N, and we have O in this reaction. Looking over here on the left, Li is by itself. There is nothing, so that means its oxidation number would be 0. Zn on the right is by itself, so its oxidation number must be 0. Oxygen always has an oxidation number of -2. And now we just check to see for the pieces we're missing. We're looking for Zn and N on the left and Li and N on the right. So here we know that NO3 has a -1 charge. There are 3 oxygens, so that's a -6 worth of charge that they're contributing. That must mean that the nitrogen is contributing +5 to it to cancel out most of that negative. Same thing over here, so nitrogen also must be +5. And then if we know that NO3 is -1 and there's 1 Li, well, Li must be +1 over here. And if it's NO3 must be 1 and there's 2, then Zn must be 2. Hopefully you're getting pretty good at this whole figuring out oxidation numbers of each piece, but now we can actually split them into our half reactions. So normally the way this is going to look, and I'm actually going to, on my computer real quick, pull it up and check. So it actually asks you half reaction 1, RxN1, and then half reaction 2, and it makes you circle oxidized or reduced. So let's go ahead and write down our piece that we've got here. First, what do we have with Li? Well, Li is starting by itself with no charge. It's ending up as Li with a plus. That plus has to have come from somewhere, so it came from an electron being lost. Then we ask ourselves a question, is this a oxidation or a reduction? Oxidation is loss of electron, and in the process it starts here and it loses an electron. So we're dealing with oxidation for our first half reaction. And then for our second piece, we have Zn with a 2+, and that gives us Zn with no charge. That means our 2 electrons have got to be over here, and that means that it must be reduced. At the end of it, it has gained electrons. Reduction is a gain in electrons. Electrons are being added to our zinc. All right, so these are, again, really straightforward. The balancing the full reactions is going to be the next piece. I actually already have them balanced up here. If you notice, there was 2 Li and then 2 Li right here as well to make sure it worked out. And this actually would have been balanced as a normal reaction. We wouldn't have needed to worry about the oxidation numbers, but it's good practice. As I yawn, it's late in the day, I apologize. So that is writing half reactions. In the next video, which should be, I believe, separate from this, but will be attached to this, we'll talk about balancing redox reactions. I'll be doing that, like I said, in the next video. So in the meantime, this is Mr. Diamond signing off. Have a great rest of your day, everybody.